In this lesson, we will convert a double precision IEEE representation, which is 64-bit long binary digit, into a decimal number. And if you recall, we start out with the formula, again on the slide from lecture, -1 to the power of the sign bit times the base, which we're in binary, that's 2, and that's going to be the exponent plus bias minus the bias. So I'm just going to say for short EB minus bias. I can put that a little easier to read as an exponent. EB minus bias. And for, just so you know, this number bias in 32-bit representation, it's 127, but in 64-bit representation, we have more space available for the exponent. So that's why you can represent more numbers in double precision. So we have 11 bits available for the exponent. And so 2 to the 11, 2 to the 11 divided by 2 minus 1 is going to be 1023. So this number is always going to be 1023. So all you need to figure out is the exponent plus the bias number. And that's figured out from up here. Before we go into that, I'll finish the equation. So we have another part of the equation. So all that times 1 point the fractional part, okay? So the fractional part is again found up here in this number. So we're just basically filling in the equation. Just plug and chug. Okay, so if you notice, the sign bit is always the first bit, right? So that's right here. This is the sign bit, that's 0. And if it's a 0, that means it's a positive number, right? So we have, -1 to the power of 0, right? And anything to the power of 0 is just 1. Oops. Just put that in better here. Right? So that's just going to be a 1 for our case. And then we're going to multiply it by 2 to the EB minus 1023. So we need to find out what that EB is. Okay, so that is going to be these 11 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's your EB. And I'll put that as the next point in this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. A little bit wide on the outline there. Let's see, make smaller outlines so we don't obscure the other numbers. Okay, so we need to convert that to the decimal. That's going to be our EB. So the exponent plus the bias, actually. And I'm just calling it my own notation, EB, just so we don't get confused with the original exponent. So if you translate this to decimal, this first number is in the 2 to the 0 place, and the third number is in the 2 to the second place, right? So that's 5. And then this number over here is in the 2 to the 10 place, which is 1028. So then if you add those all together, so excuse me, this is 10 to the 10 is 1024, not 1028. So I'm just going to write that down. So this is going to be 1024 plus 2 to the 4, which is 4, plus 2 to the 0, which is 1. So then we're going to have 1029. So we can put that here now. So I'm going to have times 2 to the (1029) minus 1023 times 1 point f. So the f part is the rest of this long, huge, long number. But that's a fractional number, okay? So then the first place will be 2 to the negative 1, then 2 to the negative 2, then 2 to the negative 3, because this huge, long number here is fractional. Okay, so let me show you what I mean. So this number here, first number, is in the place of a better right underneath. So this is in the place of 2 to the negative 1. And then the next number over would be 2 to the negative 2. Oops, this is times 0. And then the next number is 1, so that's 1 times 2 to the negative 2. Should be a times. Oops. And then the next number is a 1, so that's the third place. So plus 1 times 2 to the negative 3. And then all these are zeros, so that's 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4, 2 to the negative 5, 2 to the negative 6, 2 to the negative 7 is where we have our next one, which would be meaningful. Okay, so actually this first is going to be 0 anyway, so I can just get rid of that. So only the areas that have the 1s are important. I just had that first one in there to show you how to start counting from the fractional. You start with 2 to the negative 1, then the next number is 1 times 2 to the negative 2, and so on. And then you add them up. So 1 times 2 to the negative 2 is 0.25 plus 1 times 2 to the negative 3, which is 0.125, plus 1 times 2 to the negative 7, which my calculator says is 0.007825, and we need to add these up, and this is going to be our f, or our fractional part, that we're going to fill in down here in the formula. So when I add this up, I get 0.3828125. Okay, so that's going to be our fractional point that we put into the formula, right? So we're going to use this, whoops, as our fractional part. Okay, so I'm just going to copy that number down here. So I have, to continue the formula, 1 point, and this is where I put that fraction that I've got up here, 0.3828125, 3828125. So again, I'm using this number here. Alright, so now all we need to do is multiply these three things together. All we need to do is multiply these things together, and we'll have our decimal number. Okay, so when we do that, negative 1 to the 0, anything to the 0 power is just 1, right? And then 2, this is going to be 2 to the 6th power. And then this is going to be, okay, and then we have times the rest of it, times 1.3828125. Okay, so just multiply those three together, and you should get 88.5. And that is the answer. That's the number that we were shooting for, showing the conversion from double point double precision representation. And the decimal number is, the equivalent decimal number is 88.5.